Hey, how's it going? I'm Kai, and today I'm going to be going deeper into the agent class, which we've been working on for a very long time, over many, many years. And so this will be a part of the Swarms framework. You can find us if you look up Swarms on GitHub, Kai Gomez/Swarms. And so basically, the agent class is kind of like the foundation of Swarms. You're going to have a swarm, multiple agents if you do not have one really good agent. So our goal has to been to make one really good agent as best as possible, and it has a ton of features. It has so many features, and in this video, I'm going to try and go over the best ones. Um, yeah, so let's get started here. Um, so if you pip install swarms to get started, just pip install swarms. Just pip install swarms like that. Pip3 install swarms. You'll get the latest version. And then, so the setup process is once you install swarms, you have to add a workspace directory. This is where all of your config files, agent states, a bunch of data is going to be stored. You could decide what folder it's going to make a folder. It's going to put everything in there. And then you would connect your API keys, OpenAI key equals whatever. And you can use OpenAI, or you can use Anthropic API key like that, or Cohere. And yeah, that's basically the setup process. We also have a CLI that we're starting to make, so you can run agents really easily, but that's still a work in progress, and there might be some errors. So yeah, please excuse us for those errors. But yeah, if we run it again, we'll see the beautiful Swarms logo. Um, and yeah, so pretty soon you'll be able to run an agent in here, or if you have a config file, you'll be able to run it as well. But yeah. So to get started, you just import from Swarms, import agents, and then we can get started. So first we have to ask ourselves, what is an agent? And we have some docs here, agent architecture. So what is an agent? Well, first, I think an agent is it's an entity that could keep looping with itself until it knows it's made a decision that is a part of its goal or it's accomplished its goal. For example, humans are agents because when we buy food or when we get something to eat, like we know when we stop eating, we observe the state of the food, and then we know when we're not eating. And so we're essentially an agent is trying to implement the same logic, but with LLMs. And so agents and swarms are basically an LLM with this looping structure alongside RAG and alongside tools. Okay, so yeah, basically you have a task. The way that the agent works is you have a task, you have the LLM will process the task. If you give it tools, it'll use a tool. If you give it a RAG database, it'll use a RAG system. And you could store and retrieve this data. You can use any RAG system, ChromaDB, Pinecone, Llama Index. We made some examples for some of those platforms, so you can check those out if you wish. And yeah, so basically that's an agent within Swarms. We're the first people ever to make this like agent class abstraction. It's super simple. I feel like LangChain has severely like made it obscenely complicated to build agents. It's so unbelievably complicated, and that might have left a bad taste in your mouth. So, looking at the agent class, we have multiple parameters here. It's basically just plug and play. You just put whatever settings you want, and then the agent will run with those settings. So, the agent name is really important. Also, giving it a system prompt. If you saw here, I deleted this prompt. But basically, this takes in a string. These are just strings. And then here you can use model name. Here you can use any model from Light LLM. Okay, so here you can use any model. Here we're using GPT-4 Omni or we can use GPT-4o. And then here, the max loops is basically how you, like how many loops is it going to run. If you set it to auto, it'll just run forever. Or you can give it an integer, so you just give it a flat number. Here you have autosave. This will basically determine whether or not to autosave it. It'll save it to a file in your agent workspace. And yeah, so I'll delete that for now because that's already integrated. Then here we have a dashboard. Basically, this is just a dashboard of the features that it'll print the features that you have. And verbose basically like makes it super simple. Makes the logging super reliable. So you'll see a bunch of logs. And so another cool feature that we have is dynamic temperature. So every loop, within every loop, the temperature will be randomized on a scale from 0 to 0.0 to 1.0. So if you put that on, it'll be randomized. And it's a really good feature, by the way, because it makes the outputs extremely diverse, but still grounded. If you go over one, it starts to become basically schizophrenic. So you put that on, put that to true, and yeah, that's that feature. Then we have another feature where you can save the state of the agents. So you can put this in the finance agent file within your agent workspace directory. Then you could also put your username. So you can put the name of your company, you can put Kai, which is me. And yeah, so that's another cool feature. Retry attempts. So retry attempts is a pretty cool feature. If calling the LLM fails, it'll basically like if calling the retry attempts fails, if you call, like you run the LLM here and that fails, it'll retry. So if you put 3 retries, this will only retry 3 times if it fails. It will not retry it just naturally. And so that's a pretty good feature if you want to do that. Streaming, so it'll print the tokens token by token. You've probably seen it in ChatGPT. That's what ChatGPT does. Then you have the context length. This is the number of tokens that I could process here. This is 200,000, which it probably isn't. It's probably around like 168,000, but you can customize this. So I'm only going to put like 16,000 for now. So if you put return step metadata, it'll return JSON, and it'll return like a state, and I'll show you that in a little bit. And then the output type. So the output type, we can have multiple output types. The string, so if you output the string, it'll just output the whole every step. It'll combine all the strings from the steps, and then it'll output that. You can also have JSON. You can have a dictionary, CSV, and even soon YAML. If not, I think the YAML might be there already. And so we have another feature, a really cool feature, which is called auto generate prompt. And so this prompt, you just give it a name and the task here, and then it'll generate its own prompt. You don't have to give it a prompt. And so that's really fun because prompt engineering is really hard, and there's not that many prompt engineers. So if you're lazy and you don't want to build a prompt, you can do that. So yeah. And then the max tokens is max output tokens. So I think this is up to like 16,000 now. If it isn't, if it is, then you'll get an error. It'll say like, hey, you cannot run this. This is too many tokens. So keep that in mind. And yeah, so here we have, if you hover over the class, you'll see a bunch of other settings. Does this have interactive? No. So, okay, let's add interactive. So if you set interactive to true, you'll be able to chat with it in the terminal. Yeah, so here we have IT, LLM, template, loops, stopping conditions, loop intervals, retry attempts, return to history, stopping token. So stopping token is basically like if it sees this token, it'll basically stop the whole loop, and that's how it knows it's done. That's the agentification of the agents. So dynamic loops is basically just setting max loops to auto. It's just a Boolean, which is true or false. Then we have a description of the agents. So if you add a description, you could say like Yeah, so the description doesn't really go into the agent. It's just something to collect metadata on. Then we have system prompts. Then we have tools. Tools are super cool. The tools in this case are the tool is basically a callable function. So you just give it a Python function, and that's a tool. And I'll showcase that feature pretty soon because tools are super easy in Swarms. Excuse me. And then we have SOP list. These are features that basically you could give it instruction documents, standard operating procedures, if you have documentation about a certain process, and that takes in a string or a list of strings. Save state path, autosave. We talked about that. Context length, self-healing enabled. This is a placeholder, doesn't exist yet. We do not have this working yet either. Multi-model. If you have a GPT, if you have a vision model, like a vision model in a class that can accept vision, then you can activate that. You could also give it PDFs. You can give it a list of PDFs. You can give it your own tokenizer. You can give it long-term memory, which is basically just a callable with a query method. So, I'll be showing that how that works pretty soon as well. You can add another stopping token, traceback handlers, streaming, docs, so docs is like file, like it could be any file, PDF, TXT, CSVs, YAMLs, etc. Parsers, best of n, callback, metadata, search algorithm, logs, evaluator, stopping function, custom loop conditions. So you could basically say if this happens, then run the loop. Sentiment threshold, that's for like sentiment analysis. Sentiment analyzer, which is a callable. You have tool schemas, output type. So the output type we talked about, function calling type. It's a JSON, output cleaner, function calling format list, format type, which is OpenAI, the OpenAI function calling format. Metadata, output type, save style file type, chain of thoughts, algorithm of thoughts, tree of thoughts. These are mostly placeholders for now, but we're going to be making that pretty soon. We also have tool choice, execute tools. So if you wanted the tools to actually be executed when you would use them, you would say execute equals true. Where were we? Oh, where were we? Okay, wow. Okay, rules. So rules, you could say do this, do not do that. That takes in a string. Planning. Tags. You could give it tags as well. You can also integrate agent ops, tool as a system prompt, frequency penalty, presence penalty, temperature, workspace directory, timeout, created at, return step meta, tags, use cases, step pool, print everything, agent output, execute workers, artifacts on, artifacts output. Artifacts is like files, and there's still more parameters. The agent class has so many features. It's very, very interesting. So the artifacts is basically the output. Everything that the agent runs within the step will be outputted in a file that you specify. So you can use Markdown, you can use TXT, you can use PDFs. Damn, I keep losing this. Device, so you can specify what device the agent will run, CPU, GPU, if you're using local models. I can't run a local model on this, but if you had a better computer, you definitely could. Device, all cores, so that basically says you're going to use all your cores to execute this agent. Device ID, what CPU number. You can also schedule a date to run this agent. So you could say do not use cluster ops. You can say use all GPUs. And you also have a model name, which is this light LLM on the back end to use your models, and then you can give it any other arguments that you want. So if I try running this, it should work. So streaming is on. So now it's going to get the output. Establishing a Roth IRA to buy stocks and obtain a tax break. A Roth IRA is a retirement savings account that allows you to invest in a variety of assets, including stocks, while offering tax advantages. Contributions to a Roth IRA are made with after-tax dollars, meaning you do not get a tax deduction for contributions. However, the benefit is that qualified withdrawals, including earnings, are tax-free in retirement. So if I make this bigger, we can see the full output. So now you can say, how can I create an ETF for AI stocks? Super high growth. I want 40% returns on average, and I only have 40K. I only have, say, 50,000 to allocate. So now it's going to run it again. This is the second max loops. And it says investing in stocks with the goal of return 40% risk. Then it says steps to create an AI investment strategy, understanding the AI sector, research and analysis, diversification, risk management, investment horizon, allocation strategy with a 50,000 investment. Consider allocating a portion to established companies for stability and the remainder for high growth opportunities. So it says established leaders. Now let's create a table of ETFs, index funds, and more for this AI portfolio in Markdown. And so now it's going to give us the table. And so basically, if you set the max loops to auto, it'll basically keep running forever until you either quit, you quit the demo, you stop it, you do Control C, or I can show you some other cool things. And I'm probably going to have to make a specialized video just for tools and RAG, because those are their own videos, and that takes a little bit more strategic consideration to utilize properly. But these are some of the easy settings that you can get started with pretty soon. So there it gave us our fund, our portfolio, Global X Robotics and AI ETF, iShare Robotics AI ETF, ARK Autonomous Tech and Robotics ETF, SDPR, S&P, Kensho Intelligent Structures, First Trust, NASDAQ Artificial Intelligence Robotic ETF, Wisdom Artificial Intelligence, Investco QQQ Trust, and yeah, that looks like a pretty good portfolio. I'm actually gonna take a screenshot of that. And so yeah, now you just do Control C and just basically stop that from running. So it's saved in our agent workspace, and that's good for now. So if I put it to loops, if I set the loops to 1, now I can say you can add a new prompt here saying when you're done. ETFs, index funds, for AI. So now we can change the task. We could say create a table of super high growth opportunities for AI. I have, say, $40,000 in ETFs, index funds, more create in Markdown. And then we can also ask Cursor to fix the grammar because that grammar is hideous. So now if we run this, we can specify this to auto, and then now once it's done, it's going to output the token. And then if this token is in the output, it'll stop. The loop stops. And that's basically like an actual agent. Like that's how it knows like it's supposed to be finished. So it's going to make the table, and then hopefully we'll see the done token, and it'll stop. Now the agent class is still in its beginning. There's a lot of new features that we can keep adding, but we're also very interested in cutting some features. Let's see. Are you finished? And yeah, it's finished. And so it knows when it's supposed to stop. And yeah, that's been a quick overview of a little bit more advanced capabilities of the agent class. There's still a lot. Like if you go to the main code, you will see all the features. And it's like, what is that? 342. When does this start? It's almost 100 lines of different features. It's quite a bit, but it really depends on your use case. So I suggest studying this. And yeah, if you enjoy this, please help support the Swarms framework, and check it out. And also join our community. If you go to swarms.ai and you go to our landing page here, you can click this button and you'll join our Discord. And if you have any questions, any problems, any issues, please come to the Discord, ask me or someone else, and we'll be there and helping you every step along the way. And stay tuned for my next videos on tool and RAG usage. And then after that, we'll probably be doing like a lot of multi-agent orchestration stuff. So yeah, if you enjoyed this video, please like, subscribe, and hit the notifications. Yeah, I hope you had fun and learned something. Thank you. Have a good day.